the calendar. So welcome back. Happy Friday. I think we are right here. Class number 18, lesson 18. So we are going to work with radicals and products of polynomials. This is the last thing that we're going to talk about with radicals for a while. So we're winding down the exponents and radicals section of our course and starting a brand new section of our course about polynomials. You can see coming up we've got trinomials and binomials and quadratic equations. So we're transitioning out of one theme and entering a new one. But coming up, we have our one and only catch-up day for the semester. So that's this coming Monday. I had moved it from some other place earlier in the semester to here because I think that the exponents and the square roots and all that jazz are some of the toughest topics for many of my students in this class. So Monday, I have no agenda. We're just going to come in and do some problems together, right? Nothing new. Coming up on Wednesday is quest number 3. It is our only non-calculator quest or test of the whole semester. It covers lessons 14 through 18, which ends today, okay? So once we finish today, that's the end of the material for the quest. Any questions on any of that? Okay, yes. Yes, so for Wednesday's quest, you're going to bring in your own reference sheet of your own creation. You can write anything that you want on it. And in addition to your piece of paper, you're going to use my piece of paper with all the perfect powers on it and the formulas on the back, okay? So 2 pieces of paper for this quest. Any other questions? Okay. So jumping in on the top of page 141, in this lesson we simplify radicals that come from the quadratic formula and we multiply polynomials using the box method. So number 1, we will soon cover something called the quadratic formula. There it is in all its glory. Raise your hand if you've seen that before. Come on, you've seen this before. Not everybody has seen this before? Really? You haven't lived? So we are going to tackle that thing in a coming class, not officially just yet. But there is a part of the problems that we're going to do related to that quadratic formula, which we can do right now. We're going to do like the simplifying the final answer step right now, so that when we get to that quadratic formula, the finishing part will be something we'd seen before. So there's an example problem worked all the way out there. I want us to work it out together. So I think there's space on the bottom of the previous page. Can you write this thing down right there at the bottom of 140? So our job is to simplify this thing as much as possible. Again, this is going to come out of problems that we will do later on this semester, but we'll be able to do the finishing part of this right now by simplifying that expression. So first, silly little example here. If I had like 2/7 plus 3/7, what does that equal to? 5/7, easy, right? But I'm going to write it this way. Do you agree? It is equal to 2 plus 3 over 7. Right? I mean, you're doing that so quickly, so naturally you don't even realize it, but you have a lot of experience going from the left-hand side of this kind of equation to the right-hand side. But just as well, if we have something that looks like the right-hand side, we could go to the left-hand side. That would be silly in this example. It would be getting like less simple. But if you have the sum of 2 things on top of a single denominator, would you agree I can split it up into 2 fractions with the same denominator copied twice? Yes? Well, that's what we're going to do over here. That plus or minus, let's just do the plus for a second. But I can write that as 2 fractions, negative 6/8 plus square root of 48 over 8. That is just going from something that looks like the right-hand side. It's got the sum of 2 things on top of a single fraction. We make it 2 fractions added together. The plus or minus is just a little shorthand notation that means, okay, on the one hand, we're going to add them, but on the other hand, we're also going to subtract them. So we just copy the plus or minus there. If I had not said 2 plus 3, I said 2 minus 3, it would still work just as well. Okay, so now that we've got our 2 fractions, we can simplify them separately. Negative 6/8 reduces to what? Negative 3/4. Right? Just factor out the 2 from both. Copy the plus or minus. Okay, I'm going to copy the 8 that's in the bottom, but I'm going to work on that square root of 48. Is 48 a perfect square? No, it's close. 49 is perfect square, but not 48. So the best we can do is look for the perfect square that goes evenly into 48. So you've got your perfect squares on your chart. I've got them up here in yellow. And I just go through this bottom row one at a time. Does 4 go into 48? It does go into 48. It goes in 12 times. So we've already got a winner, but it turns out that you want the biggest number possible. So let's be greedy and just see if we can do any better than 4. And if not, then we'll come back and use 4. Does 9 go into 48? No, 9 goes into 45 and then 54. Skips over 48. Does 16 go into 48? $16 goes into 48. And so that's the thing we're going to use. We could continue to try to be greedy. 25 clearly does not go into 48. 36 is more than half of 48. So we've got our winner. We are going to rewrite 48 as 16 times something. How many times does it go in? 3 times. And then we've got this really nice product rule for radicals that says we can split this up into 2 radicals. I'm not going to write that step, but in my mind, I've got 2 radicals multiplied together. And then the square root of 16 is nice and comes outside as 4, which is why we wanted to rewrite 48 in this way. So equals, copying the negative 3/4 plus or minus, 16 comes outside, becomes 4. Copy root 3 over 8. And then we've just got one last step here. We are going to reduce this second fraction. So copy the negative 3/4 plus or minus. So the 2 things that are outside the radical, they work together. They reduce. What do I get when I reduce that 4 over 8? 1/2. So I won't even write the 1, but there is an invisible 1 in front of that radical, right? See the 1/2? Sometimes I see students make the following mistake. They say, okay, 8 and 48, we're going to reduce that. 8 and 48 are both divisible by 8, so they put like a 6 there and a 1 there or something. It can't. The 48 is protected inside of that radical. It is not available to us, okay? It only becomes available when we wrote it as a 16 times a 3 and the 16 came outside. Now that it's a 4 outside, now it's available, okay? So this is how we clean up things that come from that quadratic formula. Any questions? Okay, so let's go back to page 148 and we will do number 2. Did I say the right page? I don't think I did. 141, thank you. So let's change gears and talk about multiplying polynomials. We're going to learn something called the box method, which is very general, and it's going to help us with an important upcoming topic called factoring. So here's the problem, very first one here in A. It says we're going to multiply 4x cubed y to the 5th by all of that stuff. So I'm going to write that out here in this way. So this is the problem we're after, is can we multiply that thing out? We're going to highlight, there's a subtraction sign, there's an addition sign, which means that inside of those parentheses I have 3 terms separated by my highlighted things, okay? And when we have multiplication outside of addition and or subtraction, what property do we use to multiply? It starts with a D. Again, the distributive property. Remember that, right? Maybe we don't know the name 100%, but it just says multiply the thing on the outside by everything on the inside. So we would just do 3 multiplications. Fair? So I'm going to give you an alternative to this. It's equivalent. We're still doing exactly the same 3 multiplications, but it's going to be like a really visual way to think about this problem. And honestly, it's like it takes a tiny bit more time to do it the way I'm suggesting, but this is going somewhere good when we do the harder problems next class, okay? So just go with me here, even though it's a tiny bit more work to do what I'm proposing. Okay, so I have drawn a big rectangle cut up into 3 little rectangles, and on the outside, I have put 4x cubed y. Did I lose something? I did. This should have been a y to the 5th. Sorry about that. On the outside, I've got my 4x cubed y to the 5th, and on the top of each of the rectangles, I have the different terms. Negative 3xy squared, that's before the first highlighted. Negative 7x cubed, that's in between the highlighted things. And then 2x squared y, that's after the last highlighted thing, okay? So each of the 3 terms goes across and gets a rectangle up on top. And here's what I'm after. What I want to do is put into each of these spaces, there, and there, the area of that rectangle. Now it looks like those rectangles all are equal to each other and they would have the same area. That's just because it's easy for me to draw the same rectangle over and over again when I'm using Microsoft Word. So they could be different sized rectangles. The important thing is we are putting the area inside of each space. Now what's the formula for the area of a rectangle? Length times width, 1/2 maybe would be for a triangle, right? So just length times width, that's going to be the area of our rectangle. So for example, let's take a look at this left-hand rectangle. The length of this rectangle is right up there across the top. The width of that rectangle is that right there, agree? So if I can just multiply purple and orange, that would be the area of that rectangle. So let's multiply them. I'm doing 4x cubed y to the 5th times negative 3xy squared. There's no distributing here. This is just one flat out multiplication. We just shuffle the things together that go together. 4 times negative 3, that's negative 12. X cubed times x. Remember, this is where we add the powers. So how many x's do we have? 4. Y to the 5th times y squared. Y to the 5th times y squared. Again, we are adding the powers and get y to the 7. So that's it. That represents the area of that rectangle. Agree? Let's take a look at the middle rectangle. The length of the middle rectangle, I'm going to put up here in blue. What's the width of that middle rectangle? What color? It's purple again. Right? The length is up here in blue. The width is a little bit far away, but it is the same purple width that the first rectangle had. So we are multiplying now blue times purple and putting the answer in the box. Okay, 4 times negative 7, that's negative 28. X to the 3rd times another x to the 3rd. Is that x to the 9? What is that? X to the 6, right? Add the powers. Okay, I've got y to the 5th, but I don't have any y's up there. So what do I put? I put y to the 5th. We're not changing it. We're just multiplying, and it doesn't have a partner, so it just gets copied. That thing in black represents the area of the middle rectangle. Go ahead and do the same thing for the last rectangle. Carefully figure out where the length and width are, and then put the answer in the blank. Okay, what do we get? 8x to the 5th, y to the 6th. Everybody agree? That's good to me. I'm going to ask you to do something which is different from like what any math teacher has told you since you learned negative numbers. I'm going to ask you to put a positive sign in front of any positive number. So let's make this a +8. Don't do it. Don't do anything different with the negatives. If they're negative, you wrote the sign. There's no question about that. But if it's positive, we're in the habit of, like the last 10 years of your math career of not putting the plus sign. Let's put the plus sign. Okay, so we now have our answer. This thing equals when we distribute all of the stuff inside of that big rectangle. So we're just going to copy it. Negative 12, x to the 4, y to the 7. That was the green thing. Minus 28, x to the 6, y to the 5th. That was black. And then the orange, what's the next symbol I'm writing? Plus. And this is why I wanted us to write the plus. Even though normally you wouldn't put a positive sign in front of the number 8, you put it here because we are ultimately adding everything. Although if it's got a negative, we don't have to worry about it. It just looks like subtraction. Plus 8x to the 5th, y to the 6th. And that's it. Okay. Yeah, so making the rectangle is going to be the first step for these things here. And so I know that there was one row because there was just a single thing on the outside of the parentheses. And how did I know there were going to be 3 columns? What is it? 3 different what in the parentheses? Terms. 3 different terms in the parentheses. It's not about like how many letters do we have. It's not about X's and Y's. It's about how many terms. And the terms here are separated by the highlighted subtraction and additions. So you just have to figure out where the pluses and minuses are. That dictates how many columns you have. Yeah. Okay, and take a look. I drew this thing up here in green. We knew this was the distributive property. That is just a geometrical way to do the distributive property. At some point, didn't we do this thing times this thing? Wasn't that the last thing that we did? 4x cubed y to the 5th times 2x squared y, and we just put it in the last rectangle. So, like, I'm not saying there's anything earth-shattering about this. It's just a geometrical way to represent the familiar distributive property. But like I said, it's going to go somewhere good for our next lesson. Okay, moving on. Let's take a look at number 3. So in number 3, we are going to be multiplying 3x minus 4 and negative 2x plus 5. I'm just going to write that over here. 3x minus 4 times negative 2x plus 5. Okay, there are a few different ways to multiply this thing, a few different valid ways to multiply this thing. Some of you might have learned an acronym for multiplying a binomial. That's 2 terms by another binomial. What is that acronym? No? It's like a 4-letter made-up word where each letter represents another word. Starts with F. We really haven't seen FOIL before? We must have seen FOIL. Yes? Yes? No? FOIL. Oh, well, the good news for you is that I don't like FOIL, so it doesn't bother me if we don't know it. But I'll just tell it to you because I think some of us have seen it before. FOIL stands for firsts, outers, inners, and lasts, and that is an acronym to tell you how to multiply these kinds of things together. So the first terms in both, right? First term is 3x, and the other first term is negative 2x. So that is that times that. Outers, that's the stuff that's far away from the middle. So that's this 3x times that plus 5, okay? I stands for inners. That's the stuff nearest the middle. That's this times this. L, F stood for firsts. What about L? Lasts. So we multiply the last thing in each parentheses. That's this times this, okay? You could also think of it as the claw method. You can kind of see like the lobster claw there. Right? You like that better than FOIL, all right. So that's fine. Either way, it's just the distributive property. All we're saying is that you multiply everything in the first parentheses by everything in the second parentheses. And that's what this thing represents, whether it's FOIL or a claw. I'm going to give you an alternative. We're going to use a box. How many terms in the first parentheses? 2, separated by a subtraction sign. How many terms in the second parentheses? Also 2, separated by an addition sign. That is 2 rows and 2 columns. That's why this box has this shape. Let's go ahead and fill in the things on the outside. I will put 3x here and minus 4 right there. And then across the top, negative 2x and positive 5. It's totally okay if you would put those things in the other order. You know, the other thing on the column, negative 2x plus 5 could be on the left. 3x minus 4 on the top, doesn't matter. Okay, and our job is to figure out the area of each of these 4 rectangles. I will focus on this one first. And I will say the length of this rectangle is sitting right on top of it. It's just that plus 5. What's the width of that rectangle? It's this distance, which is way over here. It's the 3x. So multiply those two things and put it in this box. And we should get 15x. But what would I like you to put in the front of your 15x? A plus sign. Okay, carefully see if you can figure out what goes in each of the other three. Take your time thinking about what is the length and what is the width. Just have to go hunt around to make sure you see where those pieces are. Okay, so go ahead and check your answer with what I've written. Make sure on that 8x you put a plus sign in the front. Megan, is there a question? Yeah, there are two terms separated by that subtraction sign. The first term is 3x, and the second term is the 4. Yeah. Okay, so we've got our answer here. We're going to have to clean it up just a tiny bit, but all we have to do is read the stuff that's inside the box. So I'm going to rewrite the original problem, which told us to multiply 3x minus 4 by negative 2x plus 5. And that is equal to, and then we just have to copy the stuff that's in the box. You can put the things in the box in any order. I'm going to read across the top row first, left to right. Negative 6x squared plus 15x. That's why I like putting that plus sign there. And then I'm going to read across the bottom row, plus 8x minus 20. And this answer is almost done. Of course, we have to combine like terms anywhere we see them. Negative 6x squared. Nobody goes with that term. But the two ones in the middle, the 15x and the 8x, they combine. What do we get? Plus 23x. And then the minus 20 we're just copying. And that's it. Questions on that one? Okay, as Kara points out, you got to make sure that you can draw the box of appropriate dimensions. How many terms are there in this thing right here? 3. So that could be 3 rows in the box. How many terms in the other parentheses? 4. So that would be 4 what? Columns in the box. So that tells you what size box to draw. There? 3 rows and 4 columns. Okay, one last example before we do the activities. It says fill in the outsides of the box in order to multiply these two things together. We're not going to actually do the entire multiplication, but how many terms here? That's 3 terms, and then the other one? That's 4 terms. So clearly, the 3 has to go on the left-hand side, and the 4 has to go across the top. Okay, so again, we're not filling in everything here. We're just filling in the outsides. We're not going to do all the multiplications. If you wanted to do all the multiplications, there would be 12 of them to do. I just want to focus on the one that's circled there. So very carefully figure out which two things that are outside of that box are supposed to get multiplied so you can figure out what goes in the circle. And then do that multiplication. Find the two things that are related to that circle, multiply them, and put it in the circle. What do we get? 30x negative 30x squared. That sounds good to me. Everybody see the two things? Okay, so go ahead and move on to the next page. The first couple of examples have to do with our simplifying the quadratic formula type expressions. And then the rest of them are going to involve the distributive property, where you'll practice with the box method. Yes? Yeah, so let's try that one right now.